We are given this function ft equal to absolute value of t for one full period from minus pi to pi. We have absolute value of t. Let's graph it. Let's say minus pi to pi. This is t. Now it is absolute value of t. This means that ft absolute value of t, which is t if t greater than equal to 0. If t greater than equal to 0 and t less than pi, because we only need to consider the periods from minus pi to pi, and equal to minus t if minus pi less than t less than 0. So let's graph it on one period. ft equal to t for t positive. So here's pi. ft equal to minus t, t is negative. So it's look like this. And you copy the pattern, copy that. Yeah, so here's a graph of the function ft. Then one full period from minus pi to pi we are working with here, one full period. And then for other, you copy the pattern on this interval, and we have this. Now let's compute the Fourier series of this function. The Fourier series of ft equal to a0 over 2 sum over n greater than equal to 1 a n cosine nt plus b n sine nt. And we need to compute a0, an, bn. a0, it is 1 over pi, interval from minus pi to pi, ft dt. And because our function is defined on this 0 to pi, minus pi to 0, so we can separate this. You can decompose this into two parts. 1 over pi, the first one from minus pi to 0, ft dt, the second interval 0 to pi, ft dt. And now on minus pi to 0 you have 1 over pi, minus pi to 0 you have minus t, so this one is minus t, minus t dt. For the second one, 1 over pi, 0 to pi, ft is t, so dt. This term equal to minus t because the interval we work with is minus pi to 0. This one equal to plus t because we work with interval 0 to pi. Now we compute the interval. Minus 1 over pi inside of t, so 1 over 2 t squared, and you plug in t from minus pi to 0. That is for the first term. Second term, 1 over pi, 1 over 2 t squared, and you let t from 0 to pi. minus 1 over 2 pi 0 square minus pi square minus pi square equal to pi square. Second term 1 over 2 pi square minus 0 square. So you have minus or plus pi square over 2 pi square over 2 pi square over 2 pi, which is pi. So A0 equal to pi. So we found the first coefficient here, A0 equal to pi. Now we compute AN. For n greater than equal to 1, AN is 1 over pi, integral from minus pi to pi. So AN is a coefficient with cosine nt. So the method to compute AN is you multiply cosine mt to both sides and then you take the integral. And all term will be 0 except the one term you have m equal to n here. And this one divided by pi, we will get AN. Cosine nt times ft dt. Ft cosine nt dt. This is a formula for AN. And this one equal to 1 over pi minus pi to this one ft on the interval minus pi to pi. We have two formulas here. You separate that, you decompose that into two intervals. As before, minus pi to 0. Ft on that interval, now we can do it quickly, on that interval is minus t. Cosine nt dt. On the second interval, 1 over pi second interval is from 0 to pi. Ft equal to t cosine nt dt. So you have minus 1 over pi interval from minus pi to 0 t cosine nt dt. 1 over pi 0 to pi t cosine nt dt. Here you do integration by part. Let's compute the first integral. Recall integration by part, and there is one trick. We can choose u and v and like it is one trick. Logarithm, inverse trigonometric, algebraic, trigonometric, and exponential. So in this case you have t algebraic and cosine trigonometric. So u equal to t dv cosine nt. So du equal to dt, v equal to 1 over n sine nt. Now the first interval here, this one equal to uv minus, so uv t times this one minus interval, so the limits pi to 0 minus pi to 0 v du. V du. Du is dt. So this is what we got by doing integration by parts. So this one is you put the limit, upper limit t equal to 0. So 0 here. The lower limit t equal to minus pi over n sine n minus pi minus the second terms 1 over n from minus pi to 0 sine nt dt. The first terms is pi divided by n sine minus n pi. I just let it be for now. 1 over n cosine n pi cosine nt over n. Remember the minus on. Minus here, minus pi to 0. Now remember the unit circle. So this is 0 pi, 1 pi, 2 pi, 0 pi, minus 1 pi, minus 2 pi, minus 3 pi, minus n pi. It is here or here. Either way, sign will be 0. So the first term, 0. Sine minus n pi, 0 for all n. And we only work with n greater than or equal to 1. But either way, this term is always 0. For the second terms, we have minus, so this is plus 1 over n squared cosine 0 minus cosine n pi. So here you have cosine 0 equal to 1, cosine n pi, cosine 0 pi, cosine 1 pi, cosine 2 pi, so cosine n pi equal to minus 1 plus 1 minus 1 plus 1 minus 1. 1 if n is even. N equal to 0 if n equal to minus 1 if n is odd. So I can write as cosine nt minus 1 power n. So if n is even, this one equal to 1. If n is odd, this one is minus 1. So here we have 1 over n squared, 1 minus 1 to the n. So this is our first term. Now we need to compute this second terms. So it is exactly the same as before. Only one thing change is the limit. So I copy all of this. I only change the limit. From 0 to pi. And now we have pi times 1 over n sine n pi minus sine 0 minus 1 over n squared. So actually minus minus, so plus cosine n pi minus cosine 0. This one, sine of n pi, we talked about that before. Sine of n pi always 0. Sine of 0, 0. The first term 0. The second term, this one is 1 if n is even, equal to minus 1 if n is odd. So 0 plus 1 over n squared minus 1 to the n minus 1. This is our second terms. Now together an equal to this formula. It is minus 1 over pi times the first integral. The first one is this one. The second one. Plus 1 over pi times this. So this is, we want to have this in common. So we change the sign. 1 over pi, 1 over n squared. So 1 over, it multiplies minus 1 here. So I have 1 over n squared times pi minus 1 to the n minus 1. The second term, 1 over n squared times pi minus 1 to the n minus 1. So first terms, second terms. You have 2 over, because they are the same, these numbers plus these numbers. 2 over n squared pi minus 1 to the n minus 1. So if you want to write it a bit further, you have two cases, n is even or odd. N is odd. If n is even, this term 0, so it makes the whole thing 0. If n is odd, this term's minus 1, minus 1, minus 1, so minus 2 times 2, minus 4 n squared pi. So this is our an. So you can use either this formula or this formula. Let's do it for Bn. Bn equal to 1 over pi integral minus pi to pi ft sine nt dt. Now let's look at the Fourier series. Here's our Fourier series. Bn coefficient of sine nt. So to compute Bn, you just multiply sine mt both sides and then take the integral in terms by terms. All other terms will be 0 except this one terms, which will give us pi times Bn. So that's why Bn is this one divided by pi. Now we have 1 over pi the function is ft equal to absolute of t sine nt dt from minus pi to pi. Here we have a remark. We say that this function is an odd function, and it is the interval of an odd function over a symmetric interval. We don't want to compute the interval explicitly, carefully. We say that this function is an odd function. And this is odd function because let's call it gt. Gt is odd because g of minus t, which is absolute of minus t sine n minus t, so minus nt, sine of an angle, say theta, an angle theta here, say this angle theta, sine of theta, this point, you have minus theta, this angle, this point is sine minus theta. So see that sine of theta equal to minus sine of minus theta. So absolute of t is the same as absolute value of minus t equal to absolute value of t sine of minus nt minus sine of nt, and this is minus gt. So g is an odd function, and we compute that on interval, on an interval over symmetric interval of an odd function over a symmetric interval over a symmetric interval. Yeah, we are talking about minus pi to pi. This one will give us 0. So by this we don't need to compute that. Doing all the computation, we know that this one will be 0. So Bn is 0 for all n. You have A0, An, Bn. We can plug in the formula. Fourier series. Now we computed all the coefficients. A0 equal to pi over 2, sum n greater than equal to 1, from 1 to infinity, cosine nt. And the sum with Bn is on 0, so this term disappears. So this is our formula for the Fourier series of ft. And we know that this one is 0 if n is even. So we only have the odd term. Pi over 2 plus n is odd. So this term, the odd term, minus 4 divided by cosine nt, or we can put minus outside, minus of this, and we can even take 4 over pi outside because that is just a number. N is odd, 1 over n squared cosine nt. So here's a few terms. Pi over 2, 4 over pi. Inside you have let n greater than or equal to 1. So do n equal to 1, 3, 5, and so on. Let me write down the first few terms. 1 over 1 squared, so 1 cosine 1t. Second terms, 1 over 3 squared, cosine 3t. 1 over 5 squared, cosine 5t. The save space, I put it on top. Cosine 5t. One over 7 squared, cosine 7t, and so on. This is a Fourier series.